I'm sprung, down, she got me doing things I'll never do if you ain't been.
Okay, now I'll discuss integration by partial fractions. Our given is integration of 2x plus 1 over 3x minus 1 times x squared plus 2x plus 1 dx. Since it's improper fraction, we will use integration by partial fraction. Of this is 3x minus 1 times x squared plus 2x plus 1. Then, and on the left side, the denominator will cancel and 2x plus 1 will remain. And then for the constant a, 3x minus 1 will cancel and then a times x squared plus 2x plus 1. And then plus b times 2x plus 2 times 3x minus 1. And for the last term, plus d times x squared plus 2x plus 1 will cancel and the 3x minus 1 will remain. 3x minus 1. Okay. We let x for 0, so 3x minus 1 equals to 0. So x will be 1/3. When x is equal to 1/3. A will be 15 over 16. The continuation, now we get the value of A, 15 over 16. Now, since we don't have any values to make any constant to be 0, so we will proceed to comparison. And we will expand this 0 is equal to a plus 6b. Since we have a value for a, 15 over 16, we will substitute it to the 8. So 0 equals 15 over 16 plus 6b. We calculate negative 15 over 6 divided by 6. We get negative 5 over 32. Is equal to, for A, we have 2A. For B, we have minus 4B. And for D, plus 3D. We have value for A and we have value for B. So we will now get the value of D. Our D now is equal to is 1 over 6. We have a value for A, which is 15 over 16, and for B is equal to negative 5 over 32, and for D is equal to 1 over 6. We now proceed to the integration. We let our u to be x squared plus 2x plus 1. So our du is equal to 2x plus 2. So the integration for this term will be negative 5 over 32 times the ln of x squared plus 2x plus 1. 1 over 6 times 1 over a, our a is 2, so 1 over 2, arctangent of x plus 1. Final answer will be 5 over 6 times ln of 3x plus 1 minus 5 over 32 times ln of x squared plus 2x plus 1 plus 1 over 12 arctan x plus 1 plus c. Algebraic integration by algebraic substitution. Our example for today will be integration of dx over square root of x plus square root of x, cube root of x. For this case, our first step will be get the LCD of the exponent, or d to be 6 root of x, and then we will let 6 to be outside integration. D squared minus c minus 1 plus 1 over d plus 1. And then we will substitute it here. See the integration of d squared minus d plus, or minus 1 plus 1 over d plus 1. d times 1/3 square root of x minus cube root of x over 2 minus 6 root of x plus ln of 6 root of x plus 1 plus 3. And here's our final answer. Integration of dx over square root of x plus square root of x, cube root of x. For this case, our first step will be get the LCD of the exponent. X raised to 1/2 plus x raised to 1/3. So 1/2 plus 1/3. 1/2 plus 1/3 is equal to 1 over 6. So we let our d to be 6 root of x. And then we will extract the square root of this, and then it will be z6 is equal to x. And then get the differentiation of this. z6 is equal to x. It will be 6z raised to 5zz is equal to dx. And we will have z squared minus z minus 1 minus 1 plus 1 over d plus 1. And then we will substitute it here. And then 6 integration of d squared minus d plus, or minus 1 plus 1 over d plus 1. d. And then we will have this 6 times our petal pen has no ink. Will be z cubed over 3 minus z squared over 2 minus c plus ln of z plus 1 plus c. But what is our z? Our z is the 6th root of our square root of our z is the 6th root of x, and then our z squared will be the cube root of x, and our z will be 6th root of x. So our answer will be times 1/3 square root of x minus cube root of x over 2 minus 6th root of x plus ln of 6th root of x plus 1 plus c. And here's our final answer.
I'm Rod Carlitos, and I'm here to show you on how to solve an integral problem using the half-angle substitution, so I hope you understand. So in here, given the problem, integral of sine all over 2 plus sine x dx. So in problem, solving these things that you should need to understand and you should remember. So first things first, you should always remember to let z is equals to tangent x over 2 sine x is equals to 2z all over 1 plus z squared, while cosine x is equals to 1 minus z squared all over 1 plus z squared dx is equal to 2dz all over 1 plus z squared. So after knowing what to substitute, we can now solve this problem. So bringing out the constant, this will be equal to 9 integral of dx all over 2 plus sine x. After simplifying, remember that we can substitute two of our variables here, such as sine x and dx. So substituting it will be equal to 9 integral of dx, which is equals to 2dz all over 1 plus z squared all over 2 plus sine x, which is 2z all over 1 plus z squared. So this will now become to 9 times 1 over a tangent inverse u over a plus c. Now be equal to, remember that a squared is your 3/4, meaning a will now be equal to square root of 3 over 2. So here 9 times 1 over a, this will become 9 all over square root of 3 over 2 tangent inverse u over a. So u, this is your u squared, which means the u is z plus 1/2 all over a, which is again square root of 3 over 2 plus the constant c. We will need to simplify this fraction, and of course this part. This equation is now our final answer, because we cannot simplify any further. So this is how you solve an integral problem using the half angle substitution. So always remember to substitute and let z as tangent x over 2 sine x as 2z all over 1 plus z squared cosine x as 1 minus z squared all over 1 plus z squared, and dx is equals to 2dz all over 1 plus z squared.
So to make the explanation more concise, I created a chart wherein it shows the different values of sine. It will be u over a, which is equal to the square root of a squared minus u squared, a cosine theta, which is a squared minus u squared, and so on for the other values. So we'll move on to our second example, namely the antiderivative of 1 over 36 plus x squared dx. So I'll equate it as square root of dx over 36 and 1 plus x squared over 36 in order to factor it out. So as we all remember, 1 plus tangent squared theta is equal to secant squared theta. The formula showed here, this will be considered as tangent squared theta. Well, as you can see, we have there x squared over 36 is equal to tangent squared theta. Simplifying it, we will have x over 6 is equal to tangent theta. And if we were to locate the value of x would be 6 tangent theta. And the derivative of x, or dx, over theta will be 6 d theta. Yeah. So getting the derivative of x, we have dx over d theta, which is equal to 6 secant squared theta d theta. So we have d theta. So finding the value of d theta, we will have dx is equal to 6 secant squared theta d theta. So following the operation, that would leave our integral to be 6 secant squared theta d theta over 36 divided by 1 plus tangent squared theta, which can also be equated to secant squared theta, which at the same time cancelling both of these, so will leave us with 1 over 6 d theta. After this, integrating this, it would equate to 1 over 6 theta plus c. To then substitute the value of theta, which is equal to, wherein theta is equal to, getting the value of x, we will get the value of theta, which is theta is equal to 1 over 6 arctangent x over 6. So substituting the value of theta, we have 1 over 6 arctangent x over 6 plus c. We are going to learn about reciprocal substitution, or how to integrate using reciprocal substitution. Here we will find the antiderivative of 1 over square root of x times 2 plus the square root raised to 3, which can also be written as x raised to 1/2 multiplied by 2 plus square root of x raised to -3 dx. We let u is equal to 2 plus x raised to 1/2. So we'll have du as equals to 1/2 x raised to -1/2 -1/2 dx. So we shall rewrite it as this. So square root of here we can see that x may be equal to z with n as the least common denominator of the fractional powers of x. So for example, we have x raised to 1/2 over x raised to 3/4 plus 1. Well, with the least common denominators of these two, shall have with x is equals to z raised to 4 and dx is equals to 4t raised to 3 dz. After knowing the common value of our x, we can now say that this problem is equals to 4 antiderivative of z raised to 5 dd over and after integrating it, we'll have 4 raised to z raised to 3 over 3 minus 1/3 z raised to 3 plus 1 x. When we have z is equals to 2, we have x the square root of x. When z, we have the 4th root of
I will teach you on how to integrate by parts. So let's start by answering this example. Integral of x times e raised to x dx. So for answering this kind of problem, we follow this rule. L for logarithmic, I for inverse, A for algebraic, P for trigonometric, E for exponential. So in this case, algebraic comes first with exponential. So we let the value of x be equals to u. And dv equals to ex. So du v equals to dx and v equals to ex. So integration by parts, we follow this formula. Integral of u dv equals u times v minus integral of v du. So for the solution, we just substitute our values to the formula. So integral of u, which is x, dx times dx equals to our u, which is x times v e raised to x minus integral of v dx. So in some examples, when we substitute our given to the formula, we find a term that which is not integrable. So if that happens, just simplify it until you get a value which is integrable. For in this case, integral of e raised to x dx is already integrable. So you just integrate it and we get the value ex times e raised to x minus e raised to x, which is the integral of this one, plus c. Simplifying it will be equal to e raised to x quantity x minus 1 plus c. So that's how we to integrate by parts.